Welcome back to the new class. Now today's topic is forces between two infinitely long straight parallel wire carrying current. So we will discuss these things today. So first of all, we will think over the two long straight wire carrying current in the same direction. First condition. Suppose the two currents carrying in this wire and in this wire. Suppose it is X and it is Y. These two wires are parallel to each other and they are separated by distance D. From this current I1 is flowing, from this current I2 is flowing. If suppose current flowing through this wire, definitely according to right hand thumb rule, the current is in this direction here. So at this point the magnetic field at this point will be here now, that into the board, and due to this you will see again using the right hand thumb rule, the magnetic field due to this I2 current at this point is outward from the plane of the board. I think it is very clear. So magnetic field at this point is, suppose here, this is B1 due to this I1 current. So value of B1, this will be mu naught by 4 pi 2 I1 by the distance D. This is the value of this B, and direction you know, inside the board here. So magnetic field on this one, due to this we are going to find out. So we are going to find out magnetic force experienced per unit length of the wire Y. This is suppose F2 according to the formula BIL. So magnetic field here B1 into current I2 and length is assumed unit 1, we will write 1, then it is B2 I2. This is the magnetic field here, magnetic force. So we have calculated the magnetic force here. This is BIL. So now we are going to put the value of here, now it is B1, put the value of B1 from here. This equals to mu naught by 4 pi 2 I1 by D, this into I2. This equals to mu naught by 4 pi 2 I1 I2 by D. This is your magnetic force at this point on this wire due to this. So first of all we will see here now the direction using the Fleming's left hand rule. This is current is flowing in this direction. This is the direction of the current, and this is here the magnetic field. Then force acting on this one, on the wire Y2, that will be towards X, and we will name it the force F2 here, this F2. Now we will think over this wire X, through which I current flowing. Now think over this I2 is the current flowing through this wire Y, and at this point direction of magnetic field from outward from the board right now. So magnetic field at this point will be here B2 due to this. So value of B2, that will be equals to mu naught by 4 pi to I2 by D. Similarly, we are going to find out the force here, magnetic force per unit length. So how much value of the force is experienced by this wire due to this current? So that is, suppose F1 is equals to magnetic field B2 into this current I1 into unit length. This will be equals to B2 I1. Now putting the value of B2 from here, mu naught by 4 pi 2 I2 by D, this by I1, and this equals to mu 2 by 4 pi then 2 I1 I2 by D. I think it is very clear. So force of this one is also known, but we have to know here the direction of the force on this one. Think over this. Current is flowing here in this direction and this is here, it is outward, then force will be here in this direction F1 towards this Y. So we will see the magnitude of the force F1, this is, and F2, both are same but their directions are opposite. They are, we will see, these two forces pull these two wires each other, so they will attract. Here we will see that this portion is, I think that it is very clear. Now the second condition is, we are going to think over this, two infinitely long straight wire carrying current in opposite directions. So now here again X and Y, two current carrying conductors, and now from X1 I current flowing, Y through Y I2 current is flowing. Since they are parallel to each other and their distance between them is D. So here we will see again, due to this magnetic field, current is flowing in this one, in this direction. So magnetic field here now is found again inward using the right hand thumb rule, and due to this here now current is flowing through this. Think over this, current is flowing here now through this in this direction, so you will find it is also inward here. Now we are going to find out magnetic field due to this at this point on this means wire Y, that is B1 is equals to mu naught by 4 pi 2 due to this I1 by D. This is your magnetic field at this point and this is this here magnetic field B1. Now we will see the magnetic field at this point. We will see the magnetic field at this point is in this direction, that is B2. So we are going to find out first magnetic force experienced per unit length of the wire Y using again F equals to BIL. So force on this one F2, this will be equals to, the same formula will be used, BIL, that is formula here, B is B1, then current flowing through this I2 and this equals to mu naught by 4 pi to I1 I2 by D. This is the force acting on this one. But the question is here, what will be its direction? Direction of the force is away from this side using Fleming's left hand rule. So direction of the force is in this direction, that is F2. Now think over this. Value of B2, this will be equals to mu naught by 4 pi now 2I2 by D, where this is the magnetic field due to this wire, so we have to take this current I2. So force on this one will be here F1 using the same formula BIL. Here we will see that for the unit length, that force will be here again B2 I1. This equals to, putting the value this, mu naught by 4 pi, this is 2 I1 I2 by D. Again we see then force F1 and F2 are equal in magnitude, but direction of the force, that will be here away from the Y in this direction. This is the force F1. So we will see these force F1 and F2 are equal in magnitude, but they are directed away from each other. So these forces repel, and two wires here, these two wires repel each other. Now one thing is very important, and that is the question asked in the examination after that. Define ampere, 1 ampere. So we know very well then force experienced per unit length of the two infinitely long parallel wires carrying current I1 and I2 is given by this formula. Given by this formula here, that is force. Value of force is this. So if distance is D, suppose now distance D is 1 meter. Now D equals to 1 meter. And suppose I1 is equals to I2 and this equals to 1 ampere. This is the current here. 1 ampere we can write like this also, 1 ampere. So putting the values of all these in this equation. So mu naught by 4 pi, that is 4 here. Now we will put the values of each and everything, that we will see that it is 4 pi into 10 to the power minus 7 by 4 by here 4 pi. Then we will see it is value of this 2 is also left, then 2, then we will write here now it is 2 into 10 to the power minus 7 Newton per meter. So ampere, 1 ampere is the current which is maintained in two infinitely long parallel wires of negligible cross-sectional area separated by 1 meter in vacuum experiences a force of 2 into 10 to the power minus 7 Newton on each meter of the wires. So thank you very much. We will meet again in the next class. Thank you.